The lesson outcome for this video is solving systems by graphing, and this video will talk about how there are actually 3 solution options. Let's think for a second about the previous lessons we've done on graphing systems. We've found out that the lines intersect, or intersecting lines, and then we know that our solution is the point x, y, where they intersect. So that point where they are both true. Well, sometimes that doesn't happen. So let's look at this next example. This first line right here, y equals 3x minus 7, is in slope-intercept form. And so we need to write down the slope, which is 3, and we need to write down the y-intercept, which is negative 7. So I'm going to plot that negative 7 on our y-axis. Of course, oops, that's not negative 7. All right, so negative 7 on our y-axis is right here. And then we're going to use a slope of 3. So we're going to rise 3, 1, 2, 3, and run 1. And we'll get to this point right here. So now we graph or draw our line through those 2 points. That's not going to work. All right, draw our line through those 2 points. All right, now let's graph the second line that I have listed. This is in point slope form. Point slope, and that means we need to write a point and the slope. Remember that your point comes from the x and y coordinate in the equation. So here's x, so it says minus 5. We're going to write a positive 5 here. And then our y value, it says y plus 2, so we're going to write negative 2 right here. And then our slope is 3. So I'm going to plot the point 5, negative 2. 5, negative 2 is right here. And then we're going to use our slope of 3 to rise 3, 1, 2, 3, and run 1, which means we get this point right here. And now we are going to graph that line. So what happens with these 2 lines? Well, they will never intersect. They have the same slope. Did you notice that? 3 and 3, which means they rise 3 and run 1 all the way through the entire line, and so will this one. So there will never be a place where these 2 lines intersect. Therefore, these are called parallel lines, and parallel lines, well, the solution's a little bit different. The solution for parallel lines is that, well, there is no solution. No solution, because there's no place where these 2 lines intersect. So we have intersecting lines that have one solution point when the 2 lines cross. We have parallel lines, which means there is no solution. And then we're going to look at one more example. What happens if, when we graph our lines, they are the same line? Let's look at the next example. Okay, so let's take a look at this next example. This first equation is in standard form. And when an equation is in standard form, we typically use the teeny tiny table. So I'm going to put a 0 in for x and solve for y, and put a 0 in for y and solve for x. If I put a 0 in here for x, ignore this. I divide both sides by positive 3, and I get 4. Show that work if you need to. And if I put a 0 in for y right here, and I ignore all this, I divide both sides by 2, and I get x equals 6. So I'm going to plot my points at 0, 4. On the y-axis, I have 4. And then 6, 0 for the x-intercept, which will be right here. So I go ahead and draw that line. So I'm going to draw that line. All right, so let's see. I'll draw that line as best I can with this iPad. Sometimes it's not the easiest. There we go. So there is that line. Okay, so now we're going to go ahead, and we can put arrows on the ends here too. Now we're going to go ahead and draw our second line. So this is in slope-intercept form, and our slope is negative 2/3, and our y-intercept, pardon me, and our y-intercept, or b, is 4. So I'm going to begin at 4, so I put a point on the y-axis at 4. Notice it's on the same dot we already had for our red line. And then we're going to go down 2 and right 3, and we get to this point right here. And so now if we draw that line through those 2 points, the purple points, we will get the same line. Oh my gosh, sorry. This won't let me. There we go. We're going to get the same exact line. Well, if we have the same line, then the solution is any point that's on that line. So there is what we call an infinite number of solutions. Now, it doesn't mean that every single point is a solution. It just means there's an infinite number of them, because any point on the line, either line, the red line or the purple line, because they're the same line, any point on those lines is a solution. So the point 3, 2, that is a solution. The point, let's see here, 9, -2, that's a solution. So there will be an infinite number of solutions. So the solution of a system does depend on whether the lines intersect, are parallel, or are the exact same line. Again, intersecting lines have a solution that looks like this, an x and y coordinate. Parallel lines have no solution. And the same line has an infinite number of solutions. More practice on this in class.